Hello everyone, I'm Faryal Bahawi, and today I will be presenting my NLP project with the name of UniGuide AI, which is a retrieval augmented generation system designed to answer admission questions for the University of New Haven. So this project focuses on building a question answering system using RAG, which combines retrieval and generation. The domain is higher education, especially University of New Haven admissions. The system answers common questions about application requirements, deadlines, tuition, and international student policies. For the data set, I used official admissions content, including requirements, deadlines, frequently asked questions, and program-related information. So instead of relying on general knowledge, the system uses trusted institutional data to answer questions. The main objective of this project is to generate retrieval grounded answers. That means the system first finds relevant information and then uses it to generate a response. And this helps ensure that answers are accurate, context-aware, and not fabricated. Another key goal is reducing hallucination, which is a major issue in language models. And also, finally, we can say that the system is designed to provide clear and simple answers that are actually useful for students. The motivation behind this project comes from a practical problem. Admissions information is not missing, it's just hard to access. So students often have to go through multiple pages to find simple answers, and many end up contacting the wrong office. At the same time, staff repeatedly answer the same basic questions. Another major issue is that large language models often generate incorrect answers. And so this project addresses all of these problems by creating a system that gives centralized, accurate, and reliable answers. Now let's look at how the system actually works. First, I collected 7 admission documents and converted them into text files. Then I performed text chunking, where each document is split into smaller chunks of about 300 characters. Next, I generated embeddings using the model All-Mini LM-L6, which converts text into numerical vectors. For the retrieval, I used cosine similarity along with keyword boosting to find the most relevant chunks. And the system retrieves the top 5 chunks for each query. And finally, these chunks are passed into a LLM to generate the final answer. I used 2 models, Gamma to be as the main model and Distal GPT-2 as baseline. And this comparison is important because it shows that not all language models perform equally well in a RAG setup. To evaluate the system, I used 4 criteria: accuracy, relevance, groundedness, and clarity. I created 10 domain-specific questions covering different admission topics, and each response was scored from 1 to 5 across these criteria. And then I compared the performance of both models, which I will then show you in the demo. The results show a clear difference between the models. Gamma achieved an average score of about 3.7 out of 5, and Distal GPT-2 scored around 1.05. So Gamma produced correct and grounded answers in most cases, while Distal GPT-2 often failed by repeating the questions or generating incorrect information. This demonstrates that instruction-tuned models are much more effective in RAG systems. There are 4 main findings from this project. First, instruction tuning is critical. Without it, even with good retrieval, the system fails. Secondly, we can say that RAG significantly reduces hallucination by forcing the model to use real data. And thirdly, retrieval quality is very important. In some cases, the system initially retrieved irrelevant chunks, which affected the answer. And this was improved by adding source-based boosting. Finally, chunking also matters. Since I used fixed length chunks, some sentences were cut, which sometimes reduced answer quality. To conclude, I will build a working RAG-based system for admissions question answering. The results show that combining retrieval with an instruction-tuned model significantly improves accuracy and reliability. This project also highlights that both retrieval and generation components are equally important, and for the future work, I would improve retrieval speed, refine chunking, expand the dataset, and build a user-friendly interface. Thank you. So here is the full implementation. As you can see, the notebook is clean and well structured. I loaded the data. Here I chunk it. I generate embeddings. I built the retriever here. Some test questions, the evaluation of 10 questions. And I pass everything to the language model here. So I run both models on 10 domain-specific admission questions, Gamma 2B, and the Cell GPT. And here, here, Gamma 2B, it averaged 3.7 out of 5 and won all 10 questions. The Cell GPT-2 averaged just 1.05. It consistently looped and hallucinated, which actually highlights exactly why instruction tuning matters in a RAG pipeline. And now let me show the system running live. Here I built a simple radio interface so you can see the full pipeline in action. So I can choose a question from here. What English language test scores are required for international students? Ask UniGuide AI, and here is the answer. From Gamma 2B, we can see that the answer is correct. And you can also see the Distill GPT answer as well, which hallucinates. Let's try some other questions. What's the application deadline? And it says that May 1, and again, this model hallucinates. And again, we can try another question as well. What documents are required for graduate application? And here it says that a complete answer. And again, the still GPT hallucinates here. So that's all. It's UniGuide AI that I created, a RAG system that retrieves from official UNH documents and generates accurate, grounded answers for prospective students. Thank you.